Hello everybody, this is Dr. Christopher White, and in this presentation we're going to be continuing looking at plate tectonics. So this following presentation is going to correspond to section 3.4 of your textbook. So in the previous presentation we'd been looking at topographic data, earthquake data and volcanic data, and we'd begun to suggest the possibility that this data could be used to show us the position of the plate boundaries. So in this diagram here you can see what we've got is a combined diagram which is showing us the earthquake data in yellow and the volcano data in orange. And what you're obviously going to be able to see is there's a pretty decent correlation on the whole between the earthquake data and the volcano data, but not all areas that have lots of earthquakes are associated with lots and lots of volcanism. Now, if we use this map as our guide to mark out where the plates are located, we produce a diagram that looks like this. So in this case, you can see we have all the different plates. So if we look at this diagram here, you can see there's a feature right here ringed by both earthquakes and volcanic activity on its western and eastern side. Here it is here, that's the Caribbean plate. You can see we have another area here. Once again, ringed by earthquake activity, has some volcanic activity as well, especially along its northeastern margin. That's going to be the Cocos plate. In terms of the African plate, we can see here's the edge of it coming all the way around here, comes up along the south coast of Europe and then comes back around there. So once we accept that we can use the earthquake data, the volcanism data and mountain data to be able to work out where the plate boundaries are located, we can obviously split up the surface of the Earth into the individual plates, which are all moving relative to each other. And of course, we always need to remember that the plates are not exclusively one type of crust. So in the case of the African plate, we can quite clearly see here, we have the continental crust of Africa itself, but attached to that continental crust we have rather large areas of oceanic crust. So don't think that a tectonic plate is exclusively going to be one type of crust. It can happen in some cases. So if we look over here, we have the Nazca plate. You can see that consists exclusively of oceanic crust. So you can have some plates which are exclusively one type of crust and some plates which are a combination of both types of crust. So always bear that in mind. And as we've discussed, these belts of activity, both belts of tectonic activity, allow us to split up the lithosphere into the tectonic plates. And obviously, using some common sense, we can then work out which way these tectonic plates are moving relative to each other. So once we accept we have these plates, we can therefore work out the scenarios that will occur. And we've already gone and discussed this. We've already discussed that once we have the plates, well, we know that one of three things can happen. Plates can move away from each other, plates can move towards each other, or the plates can move past each other. And so this is then going to create three distinct types of boundaries. One type of boundary where the plates move away from one another, one type of boundary where the plates are moving towards each other, and one type of boundary where the plates are moving past each other. And each of these types of boundaries is given its own distinct name. So in the case of a situation where we have two pieces of crust moving away from each other, so we have one plate over here and one plate over here, so this plate's obviously going that way, this plate's going that way, well, we're going to end up forming our rift down the middle here. This is going to be called a divergent boundary because the plates are diverging from one another. In the case of a situation where we have plates moving towards each other, that's going to give us a convergent plate boundary because the plates are converging on the same location. So in this case, we can see we have this piece of oceanic crust here is moving eastwards. This piece of continental crust here is moving westwards, and well, they're going to crash into each other head on. And finally, we have a situation where we have pieces of crust simply moving past each other. So they're not moving away from each other, they're not moving towards each other, they're simply moving past each other. And that gives us a type of plate boundary like this one right here, which is referred to as a transform boundary. It's also sometimes referred to as a conservative boundary. So if we look at our plate tectonic diagram and we apply our three different types of plate boundary to it, we can start to define what each type of boundary is. So remember, our types of boundary are of course divergent, plates move apart; convergent, plates move towards each other; transform, plates move past each other. So in the case of the ridges that we can see moving down the middle of the ocean, so we can see this is the Mid-Atlantic ridge here, we can see that this is going to be a divergent plate boundary where the crust is going to be moving apart. And so we can see this is going to create this ridge-like feature with a rift in the middle, and that's when new crust is going to be made. In the case of the convergent plate boundaries marked out here in red, we see that they tend to be associated with mountains. They tend to be associated with lots of earthquake activity. Most of them are associated with volcanic activity, and now that can be volcanoes in mountain ranges, like the volcanoes of the Andes, but it can also be volcanoes associated with island arcs, like the Aleutian Islands. So bear that in mind as well. Now, in the case of convergent plate boundaries, we have crust which is smashing into each other. This means the crust is going to get, to some degree, destroyed. So in the case of a divergent plate boundary, we have new crust being made. In the case of a convergent boundary, we're going to have a situation where crust is being destroyed. And then finally, we have the transform plate boundary. So transform plate boundaries are primarily around to allow pieces of crust to simply move past one another. So if we look down here, we can see a situation where we have the South American plate right here is moving to the west. We then have this plate down here, which is called the Scotia plate. And the Scotia plate is on the whole relatively stable. It's not really moving very far. So the South American plate is moving westwards, the Scotia plate is relatively still, and of course that means there has to be a transform boundary along the contact between the two of them, where the oceanic crust of the South American plate can move in a westerly direction, and the oceanic crust of the Scotia plate can pretty much just stay where it is. Now, in the case of a transform plate boundary, no crust is being made, no crust is being destroyed, and so that's also why transform plate boundaries are sometimes called conservative boundaries, because the crust is being conserved. Okay, thank you for watching everybody, and have a good day.